This is the final project for CSE 490 Deep Learning. The greatest painters have left priceless artwork to us, and we're still admiring their art and style until today. It would be amazing if we can replicate some styles from them. In training images to a different style, it would be much easier to use paired photos and paintings for training, but in most cases, we do not have such ability to get well-paired data. The problem statement is how can we generate image with certain styles without having a good amount of paired data. This project is a learning and experimentation of the cycle GAN from the paper, unpaired image-to-image translation using cycle-consistent adversarial network. In this project, I trained the cycle GAN model by following the methods described in the original paper. The two datasets I'm using are both from Gogh, including photos of real-life views and stylized painting. I first trained with the Monet painting like the paper, and since I noticed example training images were very close to real-life looking paintings, so I trained a network using sketches from Van Gogh's painting, which would be quite different from the real life. To generate images in certain style, we are transforming data from domain X photos to domain Y styled paintings. First, we need a discriminator to judge if the generated image belongs to domain Y, but only using the discriminator may cause problems like generating image that look like it's an image in domain Y, but the generated image may turn out have nothing in relation to the input image. So to avoid problems like this, another generator is needed to transform the data from domain Y back to image in domain X. We need to make the regenerated input image as close as to the original input image. For discriminator, after the last layer, a convolutional layer is applied to map to a one-dimensional output, followed by a sigmoid function. Here is the ResNet block-based architecture for the generator, with 3 convolutional layers of encoder, 6 layers of residual block, and 3 convolutional layers of decoder. As a result, it takes way too long and GPU consuming to train the GAN model, and after training 100 epochs in the Monet painting dataset and 13 epochs with the Van Gogh dataset, my computer finally crashed. But I would say it is still pretty successful in generating the paintings and photos to the styles I want. Here's a demo of the notebook using the input image to generate the Monet styled paintings.